When the variable that we are trying to solve for is tied up as part of a rational expression, we have an objective, an extra objective, to eliminate the fractions and attempt to create an equation that could be manipulated through addition, subtraction, multiplication, and division. In this example, we have r, which we're trying to solve for, tied up as part of the denominator of the rational expression on the right-hand side. We've looked at a variety of strategies in this module that allow us to clear out the fractions. But the fact that we have a lone fraction on the right and a one variable on the left that we can easily put a 1 underneath, cross multiplication seems like a pretty good route. Cross multiplication is always ideal. We can't just start flipping fractions over. Those rules don't apply in the ways that we intuitively think they should. We can't just start flipping all the fractions over and end up with all these reciprocals to get r onto the top. But what we can do is use cross multiplication to clear out the fractions and isolate the variable we're interested in. So we're going to multiply this way, and we're going to multiply this way. So we end up with a equals p times 1 plus r. I am trying to isolate the variable that is tied up inside of this parentheses now. Not a problem. We can distribute the p, and then we can subtract that lone p from both sides, and then finish by dividing by p, and we get r equals a minus p over p. An alternative way to write this, because we have a monomial divisor, is to divide both of the terms in the numerator by that p, and we get a over p minus 1. There are other strategies for clearing out the fractions. You might want to think about multiplying by a common denominator, but in this example, it would have ended up with the same result. You would have multiplied p by the denominator of 1 plus r, had that lone a over on the other side. So there's options in terms of how you want to write these, but don't forget about the old classics. Cross multiplication is available in the fraction equals fraction scenario. That being said, let's try to use that again here. This situation is a little bit different. The variable that we are attempting to solve for appears in both the numerator and the denominator. I'm not worried about that until I clear out the fractions. Once I clear out the fraction with cross multiplication, then I'll worry about the two instances of the variable. We can't start splitting this denominator with the minus sign and trying to cancel out a's. It's not going to work. There's no factoring to be done. There's no cleaning up to be done. We're going to have to go with cross multiplication to wipe out the fractions and try to get all of these a's onto one side. So for the sake of clarity, that's what it would look like after you do the cross multiplication. I still have this issue of an a on the left and an a on the right. I went from an a on the top and an a on the bottom to one on the left and one on the right. If you recall from an earlier example, our goal is going to be to try to get everybody to one side that involves an a. So in order to do that, we're going to multiply out the right-hand side. We're going to move this term. We're going to move this term over to the left so that all of the business, including an a, is all on one side. We're going to factor that a, giving me 3 minus bd is equal to negative bc. And again, you might recall we have this extra factor here that we're just going to divide away, leaving us with a equals negative bc over 3 minus bd. Again, a very straightforward and simple calculation. Cross multiplication. Got us to the point where we can engage the skills that we're already used to using in this course. Factoring, moving terms, looking for a greatest common factor, allowing us to divide away at the end, reaching a simplified version for a. I made mention a few minutes ago that you're not allowed to just start flipping fractions over. And as nice as it would be to take the 3 fractions in this problem and flip them all over, then move the Q and you'd be done, unfortunately, it doesn't work like that. We have to go through a slightly different route in order to solve for the x in this type of equation. We can't just start reciprocaling everything. There's no function that says take the reciprocal of everything. When we have multiple rational expressions, whether they're on the left or the right, it doesn't matter. When we have multiple rational expressions on the same side, like we do here, cross multiplication goes out the window. Sure, you could look for a common denominator of those couple of fractions and try to put them together and then do some cross multiplying. But ideally, let's just wipe all the fractions from the very beginning and look for a common denominator of the entire thing. So if you recall from our previous coursework, we're looking for a common denominator. We're going to take the 3 factors from the denominators and multiply them all together. We get a common denominator of 3qx. That term, whoops, I'll rewrite that. My apologies, 3qx. That term is going to get multiplied by all 3 of these fractions, and we're allowed to do that thanks to the equal sign. If you multiply it on the right, you have to multiply it on the left. So we have our first fraction, 1 over x times 3qx, leaves us with a 3 and a q. The x's knock each other out. The second multiplication leaves us with a 3x. The q's knock each other out. And the last one leaves us with a 4, which was already there, and a qx. The 3's knock each other out. Since we're trying to solve for x, I see 2 iterances of the x. Let's get them to the same side as we did in the last example. I'm going to go right because that x was already by itself. 3q is still there. Let's factor the x and leave us with 4q minus 3. Dividing away that big common factor, we get x is equal to 4q minus 3 over, whoops, my apologies, I have that upside down. X is equal to 3q over 4q minus 3. Remember, this needs to be the divisor as it was being multiplied by the x. Both sides get divided by 4q minus 3. It becomes the divisor. So across these 3 examples, you saw a couple different techniques for clearing out the fractions. We have cross multiplication as a strategy for clearing out the fractions. We have our old friend, the common denominator, as a strategy for clearing out the fractions. Regardless of the approach that you take, once you get the fractions cleared out, then it becomes a new game where you're looking to see how many instances are there of that variable that I'm trying to solve for. If there's only one instance of it, great. Move all the terms away from it, divide, just like we did in the very basic examples earlier in the course. In these examples, it's likely that you're going to see 2 instances of the variable, so you need to be a little bit creative in terms of how you get rid of it. Do you need to move them to the same side like we did in this example or this example? Or are we already kind of set up with it in only one term like we did in this example, and you can easily push everything away? So factoring, post eliminating the fractions. Eliminate the fractions first, then looks to see how many occurrences of the variable you have, factor as needed, solve as needed.